Otherwise, we'll roll. So yeah, I'm just going to be covering how we think about data quality here at Crane and what approaches work for us, as well as highlight some of the principles that go into that. So quickly, we'll cover context in which we work, motivations about why this is actually important to us, the generalized approach and thought process we take to this, and then zeroed on a few examples. So our team context, so Crane is a supply chain company with about 3,000 employees, fully global. Think of us kind of like a Lambda function for shipping and warehousing. Our data team is relatively small relative to the headcount, fewer than 20 people, a relatively high developer to data engineer ratio. We have a lot of the usual use cases, right? So moving data around with automations, integrations, dashboards and workflow tools, and client-facing analytics that get embedded into other products. So our tech context, I won't spend a lot of time on, but we have kind of the classic ELT architecture. For us, one thing that's slightly less usual is that we have very few SaaS sources and mostly CDC off of owned databases. We have the usual transformation and transport and storage layers a lot of people have, and then use some conventional BI tools and have the typical, supporting cast of additional tools in terms of orchestration and CI and configuration as code and all the rest. If you look at just what's important, right, I'd say 80+% of our value comes out of the CDC, the cloud data warehouse, the BI tool pipeline. So for us, motivations for why we spend a lot of time thinking about this problem, investing in process around this problem, really comes down to two things. One is that to make any impact at all, I think all of us have experienced that you have to have a high degree of customer trust, whether that's internal consumers like execs or people in operational roles, or definitely external with clients, right, where you have even fewer chances to establish and keep trust. If there's a problem, even if it's really upstream's fault because some salesperson keyed in the wrong data or someone chose the wrong dropdown or someone sent you a malformed event, it doesn't really matter. It's still your dashboard or your integration. So it's still your problem and still up to you to own that and resolve it. So trust is one big motivator because it kind of gates all of our effectiveness. And then the other one is on the developer productivity side. Root cause analysis is really time consuming. We do a similar rotation to what was just discussed earlier, and how much of a time sink that is, right? It's largely tied to data quality. Also, developers, myself included, really hate touching things if they can't trust that it won't break. So those are the two main motivations for us. And if we kind of move on to the core principles we take or think about when we're approaching this problem. The first one is that you can't just test at one point. You can't just use one layer, right? So the defense in depth portion is pretty critical to us. Although, of course, I'd always start at the end output, the final mile, if you have to start somewhere. Really big on automation, almost over investing in automation, right? If you have boring manual data quality processes, everyone's going to be sad. People won't feel safe making changes. People will start skipping them and things will deteriorate. And then clear ownership is another essential piece. I'm sure a lot of people here who are data practitioners have had maybe the demoralizing circumstance of owning a data quality issue that wasn't really yours to own. It was really an upstream problem, like I was discussing earlier. So for us, establishing clear accountability for essentially every error, every quality issue is a key part as well. So briefly, I'll talk about one of the key distinctions we make when we're thinking about where and how to apply different data quality approaches. So here's just a kind of generic set of checks and things to think about throughout a typical data pipeline, whether it's live and streaming or batch. It's intentionally symmetrical. But the key distinction we make is how controllable it is, right? How far inside our sphere of influence it is as an individual developer or as a data team at large. So some of the things on the source side are a little bit less controllable. Like, did the data arrive on time? Someone else is sending you the event. A lot of times you have very little control over that. Is it correct in the content is normal? Very, very little control over that. Correct transformations and projections, almost 100% control over that on the typical data team, right? You control what's in your DB2 project or in your DAG or whatever else. And then Is the output content correct? You have somewhat of control over that because it passed through your pipeline process in your platform. And then you have a lot of control over, are you delivering regular updates? Say, is your DBT project running on time? What's the lag in your pipelines? That kind of thing. You have a lot more control over that. So we tend to focus in as much as possible on the higher control areas. So just dive into just two examples here, one controllable, one uncontrollable. So we think about a controllable example. So one concern you might have that's controllable would be bad deployments. I know this one's kind of generic, but think, the classic, someone made a tiny SQL change, you merged it without waiting for your green check marks, and then now someone's downstream contract is broken, or the dashboard is just lit up with red errors because you renamed a field and didn't pick that up throughout the rest of your environment. A lot of different ways to basically break downstream use cases via bad deployments. So an example for us, our goal is less than one breaking PR per month. Most months we're at 0, right? This is focusing in on the transformations, like part of our repo and what we deliver. So no rollbacks, no hot fixes, no broken contracts, right? It's the goal there. And an example of mitigation that we take is duct testing, which I'll explain just a little bit later, but is essentially, a black box testing approach. Are things the same before and after you make your changes? So then if you look at an uncontrollable example, one would be just bad upstream data entry, right? So the classic, someone entered it wrong in your ERP or CRM, whatever else. They put that the future delivery date is actually going to be in the 1970s. So some of those things, right, you can restrict in upstream systems, but ultimately you can't fully control everything that makes its way into your data platform. And so the way we address this are really kind of two different approaches. One is conditional KPIs that are very specific to the use case. So some close to real life examples for us would be no invalid future delivery dates, or all the status codes are updated within a certain SLA of the actual event. And then also sometimes it's helpful to roll those up into aggregated indexes. You can get specific or very general. So for example, it could be like, hey, you gotta have a score of whatever on our internal data quality index for this specific topic. And that's something where what goes into that index and how to score it, you want to negotiate with the actual data owners. And then the mitigation, and this is something that we apply internally without sharing too much detail, to say that there are real financial and performance management consequences to a lot of data owners based on, are they hitting the KPIs that we measure and report on? So that's really effective for making it visible if something's essentially not your fault, as well as making sure that it doesn't occur that often, and still providing people the tools to improve that over time. So really quickly, I'll explain duct testing, which is a really simple concept. And I think the reference point here is like duct typing in a dynamic language like Python, or just black box testing in general. So this is our way of keeping it really simple and providing a generalizable approach across, especially in our data warehouse layer, to make sure that we don't introduce breaking changes. It's actually something Datafult's good at. I'll let sell y'all on that one. But so given some set of input data, you apply some set of transforms, DBT, Python DAG, whatever else, and you get an output. And so that's your initial state in production. And so if you have the same set of input data, right, so temporally consistent snapshot with whatever your most recent pipeline run in production was, for example, you apply a slightly different transform. The question is your output duck any different? And if your output duck is different, then that should be intentional. So a great example of this is you open a PR to make a minor change to naming on a certain enum that goes into your master client records. And then you notice that as an outcome of that PR, your new duck has different net revenue per client. And so that's probably unexpected. You go back and debug instead of just merging that one to master. So this is actually a really important part of our process. Is kind of blankets everything and covers us for basically every PR that impacts the data warehouse. Really briefly, some alternatives and why duct testing is so convenient. This is not exhaustive, but a lot of people favor like assertion-based testing methods. So, is my customer type in this list for this golden record, is my output still the same, kind of similar? Is my data distribution still the same or roughly equivalent? These are easy to implement piece by piece, but they're really hard to scale. You never get complete coverage. It can result in a lot of noise, as well as just like it's at the end of this huge test suite to maintain. So we apply those where appropriate, but maybe more sparingly than the classic I'm going to dump everything into Great Expectations test kind of approach. And then, of course, unit testing is very thorough. It's really annoying to do in data pipelines. If you spent time mocking up the 15 inputs to your pipeline full of joins and making sure all those input sample sets cover your edge cases, you know that this is not necessarily a pleasant way to approach things in a rapid development environment. So we love duct testing. Datafold is one of the tools we use to enable that. But so that kind of covers our general approach and a few examples.
Thanks, Jared. Quick question. How many tests, like how would you estimate your current test coverage with assertion tests in your pipelines?
So it's a nuanced question because we have the classic data warehouse assertion tests around like nullability and primary keys and everything. But in terms of special case assertion tests, aside from like enums, that's probably 20% or less. So you just focus in on the high value use cases, remove all the rest of the noise, and then let that testing take care of the rest.
There was a question from Rachel. Do you use synthetic data for duct testing? And is it possible to use synthetic data for either duct testing or assertion testing?
Yeah, you can. That starts to look a little bit more like a unit testing setup. So for us, we're fortunate, and just because of our data landscape, we don't have to be quite as careful with development data as maybe a like B2C company would have to be. So for us, we just take daily, like consistent snapshots of production state. So less, even though we deploy really often throughout the day, our CI and kind of like fake prod, initial duct comparison pipelines are always built from the exact same thing. It's a lot easier to do it that way because then it's real data. You see any differences, you can investigate, and all your edge cases in production are covered because it's a real production sample at least.
Great, thank you. Thanks a lot, Jared. Our next